Assistant Professor EC Department from the college Ajay Kumar Garg Engineering College. Today I am going to start with the next part of the subject, that is data communication network. So, the topic of today's lecture are, first one is IPv4 address and IPv6 address. What do you mean by IPv? That means it is Internet Protocol version 4. Next one is Internet Protocol version 6. So, there is a very slight difference, or the length of the address, number of bits that has been considered for this address is same, else the concept behind this IPv4 address and IPv6 address is somewhat it is same, only the length means number of bits that has been required for the transmission purpose is increased in case of IPv6 as compared to the IPv4 version. Now, I will begin with the IPv4 address, and IPv4 address is a 32-bit address that uniquely and universally defines the connection of a device, for example, a computer or a router, to the internet, which means that let us say this is a network that has been set up, and these are the 3 computers that will going to form a LAN network, and this is connected to a device through a router. So, this is basically a router and this is internet to the rest of the internet. So, it can be another network also. So, you can see over here that this particular router is acting as a connecting device, which will going to connect this internet to this network, which can be a LAN or a WAN, where different devices are interconnected in a very small area, and to this certain address is required, so that we can signify that which particular device we have connected to. So, that address length is known as 32-bit address, that is uniquely and universally defined. So, which means every device or every connection is having a independent address, it is not going to be same for 2 devices. So, every device has their own address. So, the address space you can say, or the number of possibilities of different address with this 32-bit is how many, means you can say let us say I am taking 2 bit of address is possible. So, 2 bit of address means there are 4 options are available. So, that is the address space of 2 bit addresses, that is 4. So, which means 4 different combinations are made using 2 bits of information, and here we are considering 32 bits. So, 2 to the power 32 bit is the address space which will going to give us this much number of addresses, means this much number of combinations you can say, or this much number of computers are connected to each other, which is having their own unique address. So, that is the concept of IPv4 address. Now, next is how we have to write this IPv4 address. There is certain protocol that has to be followed for every language. We will see like C, C++, Python, or any language, there is a kind of syntax behind that language, or a procedure to write that particular language, that consists that is known as the protocol. So, when we are talking about this IPv4 address, it is also having a certain set of format. So, that is known as the dotted decimal notation and binary notation for an IPv4 address. Now, you can see that this is the IPv4 version, and this is separated by dots. So, that is known as the dotted, and decimal means these are having the decimal format. It is not in the hexadecimal form, it is known as the not in the octal form or the binary form, it is in the decimal format, and these are denoted separated by these points. So, this is the dotted decimal notation. Now, next one is the binary notation. We have to consider 8 bits for this, for converting this decimal into octal, where 8 bits are there. to denote this 128 bits of this information in the decimal format. So, these are the notifications that are used for the IPv4 version. So, any address which is written in this format, and you can see over here that what is the limit of this address. So, that is the case for IPv4 address. Now, next we will discuss some of the examples so that you will be familiar with what is the type of frame format that we have to consider for the IPv4 addressing. Now, first example is change the following IPv4 addresses from binary notation to the dotted decimal notation. So, what we have to consider, these are the two examples which are questions which are given over here, and we have to convert each one of this into its decimal equivalent and separate each decimal value by these points. So, that is why it is known as dotted decimal concept. So, what we will have to do, we will there are 2-3 ways, if you know, like if these are the 8 bits, first one, these are the 8 bits, we have to convert it into decimal format. So, there are 2-3 ways, like this is 2 to the power 0 plus multiplied by 1, then we have to start from here only, then this will be 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus and so on, and this will be 2, 3, 4, 5, 6, 7, 1 into 2 to the power 7. So, what it will be equivalent to? It will be equivalent to 128. So, which means this binary data is converted into decimal frame format using this type of concept. So, this is the 128 plus 1, this one is plus 1, which will be equivalent to 129. So, that is the conversion of this particular binary into this decimal frame format. Likewise, you can convert this one followed by this one. So, this will be 0.11, then again it will be 0.11 and this will be 0.39 concept which has been written over here. Now, next question is also next part of this question is also same, that we have to convert this binary notation into dotted decimal. So, this is the binary notation which has been written over here, and we have to convert it into this dotted decimal format. So, this is the very simple example. You can find out this how particular IPv4 addresses can be written in two different formats. Next one is find the error if any in the following IPv4 addresses. So, you can see over here that there are different IPv4 addresses which are written over here, and we have to find out that whether it is written in the correct format or not. So, that will going to give you another brief explanation that how this separation will be made, like this is 111.56.045.78. So, how we have to consider, there must be no leading 0. So, which means if I have to write 45, then 45 has to be written as it is. So, its correct format will be 0.56.45.78. So, this is the correct format to convert this IPv4 address to justify that whether it is correct or not. So, there should not be any leading zeros, 0 should not be included, because before any digit it does not mean anything. So, that is the correct format. Now, next one is this example, there cannot be more than 4 numbers, which means like this is the first number, second, third, fourth and fifth. This is wrong. So, we have to consider only 4 numbers, mean 4 digits that has been separated by particular distance, that has to be considered only. It has not to be considered separately, means only 4 digits numbers has to be considered. Third one is this one. There is a problem in this one, that each number needs to be less than or equal to 255. So, here a number which is greater than 255. So, 301 is greater than 255, that has to be removed. So, this should not be greater than this has to be considered. It should not be greater than 255. 255 is the maximum limit. Now, next one, fourth case is written over here. Now, you can see that in this example there are both the notifications are considered. First one is the binary form and other three cases are the dotted decimal format. So, all the both the type of notations cannot be used in case of IPv4 address or any kind of thing. We have to consider either the dotted decimal or we have to consider either the binary frame format. So, the fourth one is also correct. So, all the four is having different errors and you can find out that how we have to write the IPv4 frame address format. Now, next is in the classful addressing, the address space is divided into 5 classes. So, basically you can see in the binary notation case there are 5 different classes, class A, class B, class C, D and E. So, 5 classes are there. In each of the classes you can see over here that the first byte is reserved as 0 for class A only. First byte, that is first byte means 8 bits. 8 bits is reserved as for class A it should be 0, class B it should be 1 0, for the third one it is 1 1 0, for the class C, class D it should be 1 1 1 0 and for class E it should be 4 times 1. So, that is the case for class E. So, that is the first byte of information that has been inserted in the binary notation. Now, next one is the secondary byte which is not fixed, third byte is not fixed and fourth byte is not fixed. So, whatever data, if it is we will see in the next example also. In case of binary notation, if we consider then particular type of data has to be considered, means it has been separated, either it will be 0. So, it will going to signify that which particular addressing or class it will going to follow, like for the 0th it will be class A, for 1 0 it will be class B, for 1 1 0 it will be class C. So, this is the case. Now, in case of this dotted decimal notation you can see the same concept has been used over here, that these bytes, first byte is being fixed, like in the first case, that is the class A. First byte means 8 bits are being fixed, which ranges from 0 to 127, class B it ranges from 128 to 191, class C is 192 to 223, class D is 224 to 239, class E is 240 to 255. So, this is the case for dotted decimal notation which has been written over here. So, in classful addressing, the address space is divided into 5 different classes. So, this is the concept where we have added the IPv4 address with the, we have merged the IPv4 addressing with the different classes, where we have separated 5 different classes. Now, next is, this is the example which will going to justify that which class it will going to the particular address which it falls in which particular class. Now, you can see in this example, in this question, first two are following the binary notation. This is the binary notation and the next two will follow the dotted decimal format. So, that is the dotted decimal and this will be the binary notation frame format. Now, you can see that the first bit is set as 0, which means this is a class A address. So, we have to first consider the previous one, like you can see in the previous slide also, in binary notation the first byte is set as 0. So, it belongs to class A address. Now, the second one is 110, which means it belongs to the class C address. So, 2 bits are 1 and the third bit is 0. So, this is a class C address. Fourth and fifth. So, the first byte is 14. So, this is again class A address, the first byte is 252, again this is a class of this particular address is E. So, that is the concept of first byte, that is 14 and this is for the 252, that is the class E operation. So, that this follows the class distribution. Now, next is the IPv4 address. So, in IPv4 address, a block of addresses can be defined as this one, that is x point dot y dot z dot t by n, in which this defines one of the address and this defines the mask. So, in the IPv addressing, this is a kind of block addressing that we have to consider, that this is x dot y dot z dot t, which is a address, and this is the mask. Now, the first address in the block can be found by setting the rightmost 32 minus n bits to zeros. So, this is the first address in the block that you can find out by setting the rightmost bit as 32 minus n, and to it will be transferred as zeros. So, this is the IPv4 frame format. Now, next is a block of address is granted to a small organization. We know that one of the address is written over here. So, you can see that here x is equals to 205, y is equals to 16, z is equals to 37, t is equals to 39 and n is equals to 28, which will act as a mask, and this is the address. So, what is the first address in the block? So, how you can find out? You have to first representation of the given address is being written over here. So, this will going to signify 205, this will going to signify 16, this is 37, this is 39. We have converted this decimal into binary. If we set 32 minus n, what is the value of n? N is here is 28. So, 32 minus 28 rightmost bit to 0. So, we get this address, that will be the particular first address of the block. So, this is actually the block which is shown in the next figure that we will going to see over here. So, this is nothing, it is the address which has been written over here. So, this is how you have to calculate the starting address or the first address of a particular block. Now, next is the first address in a block is normally not assigned to any device. It is used as a network address that will represent the organization to the rest of the world. So, basically in case of the first address, if we consider over here, which is 408, which will signify the area code in which particular area you are using the device or you are connecting the two devices. So, that is the area code. Next one is the exchange office, and third one is the subscriber. So, subscriber means the user itself, which will going to signify that which particular area it will going to connect between the transmitter and receiver. Then there is an exchange office. Exchange office is basically, it means that there is an office that has been set up between the transmitter and receiver. So, that is an exchange office, and there is also an area code which has been existing between the transmitter and receiver. So, that is the area code, this is an exchange code, and this is the subscriber, which means two people are there in a network, which is the transmitter and receiver, and that will be defined by the subscriber only. Now, next we head towards the IPv6 version. What does it mean? That the first difference between the IPv4 and IPv6 is number of bits that it will going to consider. So, despite all the short term solutions, address depletion is still a long term problem for the internet. This and other problems in the IP protocol itself have been the motivation for IPv6. So, what leads to the development, what leads to the designing of IPv6? Since we have said that the total length of the IPv4 address is 32 bits. So, total address space, that is 2 to the power 32 number of users can be connected in a network, and with the increasing demand of the subscribers, like number of subscribers is increased. So, definitely we have to increase the number of bits that has been used to describe the unique address, since it is unique. So, each address can be used by only one device, that is fixed. It is not possible that same address can be used by other device also. So, that limit is fixed, 2 to the power 32 numbers of users are connected in a network. So, with the increasing demand we have to increase, and that has increased from 32 to 128 bits. So, total address space for this IPv6 version is 2 to the power 128. So, these number of users can be connected in a particular network. So, this is the starting of the address, and you can see over here that 128 bits is equivalent to 16 bytes, and it is equivalent to 32 hex digits, which means hexadecimal digits, it is equivalent to this one. Now, this is the frame address format. You can see over here, like this is FDEC, this is 0074, this is 4 times 0, this is again 4 times 0. So, this is how you have to write this 128 bits of data, means this is the this is showing the range. Now, next is abbreviated IPv6 address. Like this is the original IPv6 address which is been written over here, which is of 128 bits. This is abbreviated one, where you can see that 4 zeros that does not describe any information, it will be converted to single zero. Again this will be converted to single zero, and this will be converted to single zero. This is again, it is BOFF. This 4 bits are again, it is converted to single zero, then this is FFO. This is denoted by FDEC, and this is 0074, it is denoted by 74. So, these are basically the abbreviated address version. Next is the more abbreviated one. If you can see that these three are combined together, and there is a gap that has been created between 74 and BOFF. Again, there is not possibility of adding the gap between this one. So, this is BOFF and FFO is been transmitting the data between the transmitter and receiver. So, that is the case which has been written over here. This is the more abbreviated one. So, this is abbreviated IPv6 address, that how we can reduce the length of the address. So, these are the references, and once again I am going to start. Once again I am going to discuss that IPv4 address to summarize this one. So, there should not be any confusion between the addresses. In case of IPv4 address, the total length of the address is 32 bit. So, 32 bits are there. So, that address space will be 2 to the power 32 in case of IPv4 version. In case of this IPv6 version, the total number of bits are 128 bits are there, and the address space will be 2 to the power 128. So, these number of users, so you can see that how this number of users has increased from 2 to the power 32 to 2 to the power 128. So, these number of users have increased, they have demanded that they want to connect to the network. So, to provide them the unique address, this IPv6 version comes into the picture. So, this is IPv6. In case of this IPv6 that the length of the address is increased, and we have to denote this address or to show this address to the particular user. So, and it is not possible to remember this 2 to the power 128 bits of information which is written in the hexadecimal form to reduce the length of the address. We have to abbreviate the address, and in case of abbreviation we have removed this 4 times 0 is reduced to 0, and then it is again reduced to single 0, or a gap has been added in this IPv6 addressing. So, this is the concept of IPv6 version, and this basically going to signify the physical address of a particular device, which consists of the subscriber address, which consists of the exchange address or the local area code. So, from every why we need to understand this IPv address. IP address is basically in case of if you want to search any device, then since this address is unique in nature, so you can find out that the data which has been transmitted or created from which device, from where it has been generated or from where it has to be transmitted. So, that is the unique address. So, that is the role of IP address. So, this is all about the IPv4 and IPv6 version. These are the references that you can go through for the seeing the another the theory for this particular topic. Thank you.